All right, so in the last lesson, we talked about um, trig functions of specific angles. What we focused on mainly were those 35, 35, 90, or 45, 45, 90, and the 30, 60, 90. Okay, we talked about those. We talked about how to apply the trig functions to different things. We talked about how you could apply them using your angle of depression, angle of elevation, those types of things, how to find missing sides, missing angles. We're going to continue with that, but we did the the special ones back at the beginning up here. We did these 45, 45, 90, 30, 60, 90. But obviously, everything's not going to be 30, 60, 90 or 45, 45, 90. And they're not all going to be in quadrant one of our coordinate plane. So we got to be able to account for those in different things. So for this one, we're going to look at all four of the quadrants first off to see what they look like. Okay. Now, when you're making angles on the coordinate plane, what you want to do is you want to create right triangles to the x-axis. All right, all our triangles are going to go back to the x-axis. So in quadrant one, our triangle looks like this. Okay, there's my right angle here. This is my reference angle. That'd be my theta. Okay, now we have a point here. So what's going to happen? A point in space is going to make this triangle for us. So whatever this point might be, we'll just call it xy. Okay, and then our three sides are opposite, adjacent, those types of things. We're going to look at them in a different way today. This is your x value, whatever that might be. This is your y value. And this here is just called your radius. So that is what it would look like in quadrant one. Okay. About to go in quadrant two. All right, so I came around. Here would be my right triangle in quadrant two. Whatever this point xy would be. Obviously, x here would be negative. Okay, so be negative x. This would be negative x. This would be a y. This would be my radius. Now here's my theta. Sorry, here's my theta. Okay. And now with that, as you see, my x is negative. Your radius is always, always, always going to be positive. Your x and y's are going to be negative or positive values based on where they exist at, but your r is always going to be positive. So that's what we look like in quadrant two. Quadrant three, here's my triangle. In this case, we would have a negative x value and a negative y value to have a point here. Still have a radius, which is always positive. But then also in this case, we're going to have a negative y and a negative x. Here's my angle. And then lastly, in quadrant four, my triangle would look like this. Here's my angle. My point would be a positive x and a negative y, making this negative y here. This would be positive x. That would be my radius. Okay. Now, do you need to memorize this? No. But you just need to remember that x is your horizontal side, y is your vertical side, r is always your hypotenuse. Okay, and with that, your point would be this extreme spot away from your vertex. You always want to take your triangle and create it to the x-axis. What that does, that standardizes everything. I mean, could you take it to the y-axis? Yeah, you technically could, but then it's going to mess up your rules. All right, so we just standardize it that all triangles are made to the x-axis. That way it just standardizes everything. Okay, so that's what your triangles would look like in the 4 different quadrants. Now, definition of trig functions for any angles. Let theta be an angle in standard position, which is what we have in each one of these cases. And let P, or your point, be xy, be a point on the terminal side of theta. If r is equal to square root of x squared plus y squared is the standard distance from 0, 0 to xy, the trig functions are as follows. Now again, if you have your x value, you have your y value, you could find your r value. It's the distance formula, or it's just the Pythagorean theorem, whatever way you want to look at it. Okay? So here is your different sets of trig function values. Your sine would be your y over r, cosine is x over r, tangent's y over x, cosecant's r over y, secant is r over x, cotangent is x over y. Now, what these do for us, they allow us to take that point that makes a triangle, and we don't even have to draw it. Okay, if we draw it, we still have SOHCAHTOA. That still holds. It's no problem. But if you don't want to draw it, if you want to save yourself time, you can just use your y value, your x value, and find your r value and do it, and find all these values. So what we're going to do here, I have an example. Okay, right here. So let -3, 5 be a point on the terminal side of theta. Find each of the 6 trig functions. Now, we can do this one of 2 ways. One, we can do it just by those relationships we just talked about, which we'll do it that way, and then we'll also do it with a triangle using our SOHCAHTOA. All right, so first one, here's my point, -3, 5. Okay, now I need to also find my r. Now, by definition, our r is going to be equal to x squared plus y squared and the square root of that. All right, so let's plug our values in. We're going to have the square root of -3 squared plus -5 squared, which is my y. Okay, so I'm looking at 9 plus 25, which is going to be the square root of 34. I don't think that breaks down at all. It's going to be 17 and 2, so no, we'll just leave that as the square root of 34. So now this is my r value. So I have an r value of root 34, and I still have that point of -3, -5. That's everything I need to find my six trig functions now. So now the sine of theta is going to be y over r. So y is -5, r is root 34. Now we obviously have to simplify that because of that root on the bottom. So I'm going to have -5 root 34 over 34. Okay. Cosine, what we just saw, the cosine is going to be our x over our r value. X value, -3, r value, square root of 34. Simplify it again, -3 root 34 over 34. My tangent now, tangent is y over x. So -5 over -3, which is going to be 5/3. All right, then from there, cosecant. Cosecant is the inverse of my sine, so I can just flip everything in this row for all these next 3. So this is going to be negative root 34 over 5. Secant is going to be root 34 over -3. And the tangent, sorry, cotangent, cotangent is going to be that guy flipped. So it's going to be -3 over -5, which is just 3/5. So all I did was use that point, and I found my radius, and I just plugged those values in for the trig functions by definition. Okay. Now, let's go ahead and I'm just going to write this up here once. I'm going to make a little bit of space. So let's do this the other way once, just to make sure it's going to be exactly the same. All right, so if I have a point that's -3, -5, that's going to be in quadrant 3. And this would be my point, -3, -5. If that's the case, now this value here would be -3. This value here would be -5. This value will be √34. This is my reference angle here. Okay, so if I want to find the sine of theta, sine is going to be opposite, which is -5, over hypotenuse, which is √34. Exactly what I had by the definition. Cosine opposite or adjacent over hypotenuse. Adjacent is -3. Hypotenuse is √34. Same exact thing I have there. So what this allowed me to do was I didn't have to draw the picture to find it if I'm given that point. Okay, if I'm given that point of where the triangle is constructed, I can find my trig functions of that value without having to draw it, or if you're more comfortable with drawing it and using SOHCAHTOA, that's perfectly fine. Any questions on that so far? Okay, good. All right, so then let's just look at it. Next part we have our quadrant angles. Okay, first off, what is a quadrant angle? Quadrant angle is going to be what if something falls on one of the axes. Okay, if that's the case, you're just going to go out 1 point. Okay, so first off, just our quadrant angles. Our quadrant angles are going to be 90, 180, 270, and 360, and 0, too, really, for that matter. Those would be our quadrant angles in degrees. In radians, we'd have pi over 2. We'd have pi. We'd have 3 pi over 2, and also 2 pi. Obviously, these all match up, and then still just pi, 0. All right, those would be what we call our quadrant angles. That's the ones that just fall on the axes. So what you would use if you wanted the sine of 180 degrees, for instance, you would just use a point here. But we just go out 1 point the whole way around. So this point would be 1, 0. This point would be 0, 1. This one would be -1, 0. And then this one would be 0, -1. So then, for instance, if I wanted, let's just go with, I don't know, let's say the sine of 90 degrees. Well, the sine is y over r. Well, y is 1. R would be 1 as well. So that would be the sine of 90 degrees would just be 1. Okay, what you're going to end up having is anytime you do one of these for a quadrant angle, no matter what the trig function is, these are your only options for your answers. 0, 1, -1, and undefined. Be 0 if you get 0 over top of a 1. It'll be undefined if you'd have 1 over 0, for instance. Those are just kind of the funky ones, just kind of the special cases. All right, so that's what happens at our quadrant angles. Now, the other thing depending on where your angle is located at, you are going to have different values. So for instance, cosine of a angle in the second quadrant, we know whether it's going to be positive or negative before we even try it. Okay, so this is how this works. If I have my quadrants, quadrant 1, 2, 3, and 4, this would be something that would be good to memorize. Okay, in quadrant 1, these are all your positives. Okay, in quadrant 1, all 6 trig functions will be positive. In quadrant 2, it's going to be your sine function. Quadrant 3, your tangent function. Quadrant 4 is going to be your cosine. Now, one way to remember that is just a little phrase, all students take calculus. Let's go in this direction. All students take calculus. Okay, so what this means is no matter what the angle, if it's in quadrant 2, your sine is going to be positive, cosine and tangent will be negative. If your angle is in quadrant 3, tangent is going to be positive, sine and cosine will both be negative. Now, obviously, with this, then the ones that are paired up will also be positive as well. We focus more so on the sine, cosine, and tangent because that's just the basis for everything. Okay, now sine is paired with cosecant, so that would be a positive here. Tangent's paired with cotangent, so that would go there. And cosine is paired with secant, so that would be there as well. Okay, but based off of that, all students take calculus. Quadrant 1, all trig functions will be positive. Quadrant 2, sine is positive. Quadrant 3, tangent is positive. Quadrant 4, cosine is positive. And we're going to need that whenever we're looking at certain values and certain angles. And you're going to be given parameters at times. And you're going to need to know where things are positive, where things are negative, just in case. We're going to do an example like that here in a second. So this one here, given tangent of theta is negative 2/3, cosine of theta is greater than 0, find the cosine and the cosecant. All right, so I need to find somewhere, I need to find which quadrant tangent is negative and also cosine is positive. So if I flip back here, it can't be quadrant 1 because my tangent's negative. Okay. That's where cosine would be positive in 1. Cosine would also be positive in quadrant 4. Let's check now. Tangent, I need tangent to be negative, so therefore it would have to occur in quadrant 4. Because in quadrant 4, cosine's positive, tangent would be negative. So now I'm going to go ahead and I'm going to draw my triangle. So I'm going to be in quadrant 4. If I have tangent, that means tangent is going to be my opposite over adjacent, or also my y over x. Okay, now looking at this, this would be 3, this would be 2. I have a negative 2/3. This guy would be the negative because it's below the axis. All right, so I have 2 of my 3 sides so far. Now I just need to step to the side and figure out what my r side is now. So I have 3 squared plus negative 2 squared, the square root of that whole thing. So my square root of 9 plus 4 is going to be the square root of 13. That's going to give me my hypotenuse. So all that did so far was I was able to figure out which quadrant it's in based off of the negatives and positives of what I was given. And then I took my tangent, placed those values based off of the definition of tangent, and then just use the Pythagorean theorem or distance formula to find my hypotenuse. So then the two I'm looking for cosine, and I'm looking for cosecant. So cosine is adjacent over hypotenuse, or x over r, or sorry, x over r. All right, so adjacent is 3, hypotenuse is root 13. Okay, that's going to make it 3 root 13 over 13 after I simplify. So I'm good there. And then also cosecant. Cosecant is just going to be the opposite of sine, or just by definition, it would be my r over y. R in this case is root 13. Y is my -2. Also look at it as hypotenuse over opposite. So this will be my two values here and here. Question so far? Now I have another sample here. I'm going to go ahead and, just for the sake of time, I'm going to skip over this example here. We can look at that maybe as a warm-up to start next class. Okay, I want to get to this reference angle part. Now I already talked through reference angle a little bit with you guys, like I said, because I had it out of place. But now this is properly where it goes. So a reference angle is, we're going to turn everything into these triangles that attach to the x-axis. Okay, just like we did here. Just like we did here. And these ones we were given side lengths. Reference angle, sometimes you're given sides. So then you need to figure out where they fit. Most times when you use these reference angles, they're going to put it in 30, 60, 90, or a 45, 45, 90, that we can use that to figure out what's going on. Okay, so a reference angle, let theta be a non-quadrantal angle in a standard position. The reference angle theta is the acute angle that terminal side of theta makes with the x-axis. So what you want to do, you want to draw the angle, connect to the x-axis, and find the angle that this triangle creates. We already went through some of these. I want to go through them again though. All right, so 135 degrees, that's going to be in quadrant 2. Okay, so this would be the angle I'm talking about. That would be 135 degrees. Now what we want to do, we want to attach it to the x-axis, make that, and create that triangle right there. Now just remember where our axes are. Well, we're in degrees. This guy would be 90. This would be 180. So what we want to do, we want to find this angle right here. This is going to be my theta. Because whatever that angle trig identities we have is going to be the same as what we have for 135 degrees, because all we did was take this angle and we standardized it. So in this case, I need to find the difference of 180 to 135. So I subtract that and I find that that's a 45-degree angle. Okay, after I find that angle, then I can use that to figure out what my trig functions might be. So all I did was just standardize that angle. Second one, let's do 580 degrees. So 580 degrees, that's over 360. Now if you remember, we want to put this on a scale from 0 to 360. So I'm going to subtract 360 degrees off of 580. All right, so I have 580 minus 360, that's going to be 220. Now 220 is going to be in quadrant 3. Okay, so it's all the way around here. Now I want to take this, take it back to my x-axis. If this guy's 220, now I need to take 220 minus my 180, which in this case is going to be 40 degrees. So now this angle here is 40 degrees. I can set up and go from there. Okay, I believe we already did these other ones in class, but let's just go over them real quick. 4/3 pi. 4/3 is, sorry, it's 3/4 pi. I can't read. So 3/4 pi, it's going to be smaller than pi. Pi is over here. All right, this is going to be pi over 2. Therefore, this is going to be in quadrant 3. It's going to be right here. Take it to the x-axis. Then from the x-axis, I would want to find the difference from here to here. So I'm going to have pi minus 3/4 pi. So this angle would just be pi over 4. Okay, last one, 8 pi over 3. 8 pi over 3 is, okay, that's bigger than 2 pi. So I want to subtract 2 pi off of that. 2 pi would be 6 pi over 3. So I subtract that off, that's going to leave me 2 pi over 3. So 2 pi over 3 is the same as 8 pi over 3. 2/3 pi is going to be in quadrant 2. It's going to be over here. This is 2/3 pi. I want to take that to my x-axis. My x-axis is at pi. So subtract 1 minus 2/3. This is going to be then pi over 3. So all I did was just standardize those angles from there. Okay. Now, we are running out of time. We'll stop right there. That'll work. We'll finish this up Thursday. I'm sure there's going to be some confusion on this. It's a little bit different. It's a little bit tougher, and I understand that. So we'll stop right there. We'll pick up Thursday. Hopefully we're in person. We'll pick up Thursday right here with evaluating the trig functions using the reference angles.